Good evening, students. How are you all? Good evening, Hia. Good evening, Prapti. Good evening, Arman. I'm fine here. Thank you. Hope you're fine too. Good evening, Prathamesh. Hello, Ananya. Good evening, Prince. Yes, I will give mic option. Just give me a minute. Students, you remember I taught you about like lithospheric plates are moving. Yes, good evening, Devdarshan. Good evening, Arna. Hello, Atharv. Students, you remember whatever we did in the last class that the lithospheric plates are moving. Hi, Kunal. Yeah. So now I will continue, students. Please listen carefully. In the last class, I started this chapter called Our Changing Earth. Okay, I started with this like how the earth is changing. So we will study about the lithospheric plate movements. Okay, lithosphere is the solid part of the earth. There are plates under that which are moving, right? The whole lithosphere is broken into a number of plates. These are called lithospheric plates. You can see there they are moving on a molten magma. Okay, okay, just like if you ever make tea, this is how it will, like put a paper when the tea boils, so the paper comes up and then goes down like that, right? So that is the same cycle. The magma is also rotating like that. Okay, and due to that, the lithospheric plates are also moving. Okay, the earth movements are divided on the basis of forces which cause them. So I also told you that there are two types of forces which are causing these earth movements. One is endogenic force and one is exogenic force. Okay, so you know what is the meaning of endogenic, like which is happening inside the earth. Okay, and exogenic means it is happening outside the earth, right? Like outside something that is happening on the earth which causes some changes, right? And endogenic which are occurring from the earth. Now this evolution of landform, this part is very important. You can see that the earth movement is divided into endogenic and exogenic. Okay, under endogenic you have two types: sudden forces and diastrophic forces. Endogenic means it is occurring from within the earth. So from within the earth you have like a sudden force and then a diastrophic force. Under sudden forces you have earthquake, volcano, landslide, whereas diastrophic force is like building mountains. Mountains are not just built suddenly, just like earthquake, volcano, landslide will happen just like that. That is not the same thing with building mountains. It takes millions of years for the formation of mountains. Okay, exogenic forces, I told you there is erosion and depositional features. I told you, no, erosion when something is washed away, and when that washed away thing gets deposited somewhere, that is depositional. Erosion and deposition. Okay, now under erosional and depositional you have river, wind, sea waves and glaciers. Okay, what are the four types you have? River you have, wind you have, sea waves you have, and glaciers. That means the erosional and depositional features are rivers, wind, sea wave, and glaciers. Okay, so these pictures also I showed you. This also I explained to you under endogenic two types. I explained to you how a volcano erupts. There will be magma inside the earth that will like boil very badly, and it is like ready to come out. Okay, due to the plate movements through fissures and all, it comes out. Once it comes out, it comes out with lot of cloud of volcanic ash, volcanic bombs, which are small, small pebbles type of thing. Then the crater is formed. Okay, once the volcano erupts, a crater is formed there. Okay, ash layers and all this. Okay, a volcano is an opening in the earth's crust through which molten material erupts suddenly. How does it cause mass destruction? You know, because it will lead to biodiversity loss, ecology will be affected, wildlife will be affected, animal habit, human habitat also will be affected, right? But it's not written here, but I'll tell you there is one advantage of volcano. It makes the soil fertile because of the nutrients that are minerals that comes out with that lava. Wherever that lava flows, it deposits those kind of minerals, and that area becomes very good for agriculture. Okay. Next, we have earthquake, which I explained to you very well. That focus is the place in the crust where the movement starts. Just above this is the epicenter, okay, where actually the earthquake will occur. So suppose if I'm sitting here the most damage is caused. This is the epicenter where the most damage will be caused, because just below that is the focus where the activity first starts. Okay, and then as these ripple effect goes on, the more closer this ripple is towards the epicenter, the more damage. The more farther away these waves are, the less damage. Okay, I also told you that there are three types of waves: P waves, S waves, and L waves. Primary waves, secondary waves, and love waves. Love waves are the most dangerous. Okay, they are the most dangerous, okay, which are occurring on the surface. P waves are primary waves which move through both solid, liquid, and gas. S waves cannot move through all of them, and P waves are the first to come, I guess, and S waves are slower to come, right? That's what we studied. How can you be prepared? Okay, how can you take shelter during an earthquake? So where can you take shelter? Safe spot. So what is the safe spot? You can hide under a kitchen counter, table, or desk, against an inside corner or wall. You can stay away from fireplace areas, around chimneys, windows that shatter, including mirror and picture frame. Be prepared. Spread awareness among your friends and family members, and face any disaster confidently. That means you should not panic, students, because that can cause lot of havoc in your mind. Okay, that will lead to more issues. I want to tell you about P wave, S waves, and L waves once again. P waves, S waves, and L waves are different types of waves generated during earthquake. These are called seismic waves. P waves and S waves are body waves. That means they are occurring. Body waves means what? They are occurring in this part. They are not on the surface. Okay, they are inside that crust and everything. Okay, they are occurring in the body, meaning they travel through the earth's interior, while L waves are surface waves that travel along the earth's surface. Okay, L waves are traveling along the earth's surface. P waves are also called primary waves. Okay. Mm, so it makes the particles to vibrate in the same direction the wave is traveling, like sound waves. Okay, they are the fastest seismic waves and can travel through both solids and liquids, even gases actually. Okay. um Now S waves, I told you, are called secondary waves. Okay, they are also called as shear waves. Okay, they cause particles to vibrate perpendicular to the direction of wave travel. So wherever the wave is traveling perpendicular to that, it will make the thing to move. Okay, it causes a side to side motion in the ground, and they arrive after P waves. Then last was L waves, which are called surface waves. So the waves that are traveling on the surface, okay, they are the most damaging. L waves, um most damaging. Okay, no need to go more in depth. This much is enough for your understanding. Okay, I also told you that sometimes people can predict when an earthquake is going to occur by studying animal behavior. So fishes in the ponds, they will get agitated. Snakes, they will come to the surface. Okay. Yeah, from here I need to start. I will first read from your PPT, and Then we'll refer to the slide as well. Okay. Please listen carefully. Earthquake, a case study of Bhuj. Students, this was an earthquake that took place in Gujarat, okay, on 26th Jan, on Republic Day in the year 2001. A massive earthquake measuring 6.9 on Richter scale hit Bhuj town on 26 January 2001. Now you will be wondering, ma'am, what is a Richter scale? Students, it is a scale. Just like you use a normal scale, scientists use a Richter scale for measuring earthquake. It also has numbers from 0 to 10. Okay. On that scale, for example, 0 to 3 is like very low intensity earthquake. 3 to 5 is like, you can see here, right? Felt only a little. Over 5, if the reading is showing over 5 on the Richter scale, it can cause damage. If it is over 6, if it is 6 and above, then it is a very strong earthquake, okay, which can cause damage. And if it is above 7, it is a major earthquake. And if it is 9, 10, you know how badly that area is going to be hit. Okay, so right now also, if you Google earthquakes right now in the world, there will be some kind of the other earthquake taking place even now, but only that major earthquakes are covered by news, because they are the ones that cause damage. Okay, like you can see here, if it is up to 4.55, it is not that dangerous. Okay, but once it hits the 6 mark on the Richter scale and above, it can be very damaging. Okay, so this in Bhuj, Gujarat in 2001, 6.9 on Richter scale was there. Okay, school area was worst affected. At least 971 students and 31 teachers are feared to have lost their lives following the collapse of school buildings. Okay. 3 days after the quake, concern rose about food, blanket, and medical supply not reaching everyone. You know the condition when any kind of natural disaster happens. Food, medical supply, blanket, that, you know, you need all that, and that was falling short. Phone lines, water pipelines, and power stations transmission lines were knocked out. Okay, hundreds of fires started as charcoal cookers overturned. Okay, so you know it will affect everything. It can start a fire also, because if something is there, it can start a fire also. Emergency declared in quake zone. The president declares a state of emergency. That time, who was the president? Declared emergency. Okay. Gujarat appeals for financial help. The Chief Minister of Gujarat has launched an appeal for the center to deal with the disaster. Obviously, students, such a bad hit earthquake, now they needed monetary aid, right? So here you can see earthquake is measured with a machine called seismograph, which measures the magnitude of earthquake. It is measured on the Richter scale. Okay, and then there will be a scale called a Richter scale. And here you can see, students, this is the area in Gujarat, Bhuj, where earthquake occurred. Okay, so this is what I just read right now, whatever I read just now. Okay, now students, one thing I want to tell you, do you know section. Okay, do you know an earthquake is measured with a machine called seismograph. Okay, I will show you the picture of seismograph. This is how a seismograph looks. Okay, here is a picture of seismograph. The magnitude of the earthquake is measured on the Richter scale. An earthquake of 2.0 or less can be felt only a little. An earthquake over 5 can cause damage from things falling. A 6.0 or higher magnitude is considered very strong, and 7 and above is classified as a major earthquake. Okay. After that, your book talks about the preparedness, which we have already dealt with in the previous slide. Now, students, we will go to the next topic, which is major landforms. Okay. First I'll read, then I'll explain the slide. So please pay attention to what I am reading. The landscape is what? You look outside, you go to park, you go to the road. How is the landscape? Is it flat? Is it a bit hilly? How is the form of the land? Okay, that is landform. Okay, the landscape is being continuously worn away by two processes. Two things are happening on this landscape, students, continuously. We cannot see it because it's happening at a very small level, but it is happening every day. Which are these two things? Weathering and erosion. I already explained to you in simple words what is weathering and what is erosion. Weathering is the breaking up of the rocks on the earth's surface. So when rocks, okay, when they get broken down, that is weathering. I told you, no, washing away, something like a washing away, that is weathering. Erosion is the wearing away of the landscape by different agents like water, wind, and ice. Okay, don't get confused. Weathering means like breaking of the rock. Erosion is like some this soil has got eroded, soil erosion. The top layer of the soil has got washed away with water. Okay, so weathering is the breaking up of rocks, and erosion is the wearing away of landscape by different agents like water, wind, and ice. Now, suppose what happens if floods occur in an area, okay, that flood water will flow to one of the land areas where there is soil, and some farmer has sown some seed, but the water speed is so high that it washes away the topsoil. Okay, so that is called soil erosion. The part of the soil which was good, okay, the topsoil, it gets washed away. By what is the agent in this erosion now? It is water. Just like that, wind can also cause erosion. Sometimes there are structures which are formed due to erosion that takes place due to wind. Glacial erosion also takes place when the moving mass of ice sheets, okay, when they come down, they also cause erosion of the landscape. So I hope you are clear with what is weathering and erosion. Please let me know. Okay. Now students, when this erosion happens, okay, suppose erosion of soil has taken place. Now this water has already eroded the top layer of soil. Now it will go and deposit this eroded material also, right? Now the water which the river which was carrying all this soil, it will carry that soil somewhere and deposit also. This is called deposition. So erosion and deposition. Erosion and deposition are caused by different agents like wind, water, and glaciers. I hope that is clear. Okay. This process of erosion and deposition create different landforms on the surface of the earth. Remember, erosion and deposition only is creating different types of landforms on the earth. Okay. Now we are going to talk about in detail the work of the river. This slide already I explained through whatever I have taught you. What is weathering? Breaking up the rocks on the earth's surface. Okay. So this breaking up of rock can happen due to the time, due to temperature changes, due to the changes in the chemical structure of the rock inside something, right? So it will lead to breaking up of the rock. Erosion is washing away of something, okay, and when that thing is washed away, it could be by river, it could be by water, I mean to say, it could be by wind, it could be by ice, and this eroded thing gets deposited, okay, gets deposited also with the help of the same agents of deposition, wind, water, and ice, create different landforms on the surface of the earth. Okay, now see here, breaking up of the rock, okay, and erosion, washing away of this, okay, we'll study in detail. Now students, the first thing that we are going to study is work of a river. So I told you river is one of the agents of erosion and deposition, right? So now we are going to study the various landforms which are created due to the river. Please pay attention. The running water in the river erodes the landscape. When the river tumbles at steep angle over very hard rocks or down a steep valley side, it forms a waterfall. You can see here, this is an image showing waterfall. How does the river become into a waterfall? How does it form waterfalls? When the river is moving, students, it has to encounter cliffs. Okay, you know what are cliffs, right? They will be like huge structures which don't have which are not continuous, and it's like if you look down, it's a valley or it's a low land down there. Okay, so what happens, these cliffs will be there, right? Now when the water is flowing, it where will the water go? It will fall down the cliff. So these are the cliffs through which the water falls down and forms waterfalls. Is it clear? That is the first thing that the water the first what you say, landform which is formed by water. Clear? As the river enters the plain, it twists and turns, forming large bends known as meanders. Students, what happens is, I told you how the river starts its journey. This is a mountain region. The river starts its journey from the mountains, especially all the North Indian major rivers, Ganga, Brahmaputra, and Indus. Once, and all the rivers actually, even the southern rivers also start from hills. Now, students, when the water is flowing, when the river is flowing from the mountains, there will be many cliffs on the way, right? That time it forms waterfalls. Once this river comes in the plain region, you know, plain region is little bit flatter compared to, it also has bumps and all that, but it is flatter, right? That is why it's called a plain compared to a mountain. When it forms, when the river, you have to imagine now, okay, I'm telling you like a story. When the river is flowing on the plain region, what happens is, it will twist and turn. Okay, why is it twisting and turning? Because load is increasing, decreasing. What load? Sand, silt, clay, whatever it has brought with it. Now, because its velocity was very high, at high speed, because the slope of the mountain is like this. But now when it is in the plain, it will have that load. So it will go like this, it will go like this, it will go like this. In English, we say meandering. Okay, the path of the river meanders, so it forms meanders. Okay, meanders, you can see it, they look like this. Okay, meanders look like this. So when the river meanders, we call that this landform formed by the river is called meander. Clear? Due to continuous erosion and deposition along the sides of the meander, the ends of the meander loop come closer and closer. In due course of time, the meander loop cuts off from the river and forms a cut-off lake, which is called an oxbow lake. Students, what happens? Listen carefully. Now, when the river is meandering, at this place it will deposit something, sand, silt, clay. Okay, then at this point it will deposit something, sand, silt, clay, because on the way it is depositing also and going, which makes the northern plains fertile. It is depositing alluvium, it will deposit here also. Once so much deposition has taken place at one place, what happens? This thing will be cut off, it will be cut off, and it forms an oxbow lake. Okay, that is why the name oxbow lake, because it looks like the, what you say, the feet of the ox. That is why oxbow lake. Is that clear? These are also called as cut-off lakes. Okay, this leads to the flooding of the neighboring areas. As it floods, it deposits layers of fine soil and other materials called sediments along its banks. This leads to the formation of a flat, fertile floodplain. Floodplain, very easy to understand. Plain area where the river is flowing and the river has flooded that area, which forms a floodplains. So floodplains are areas that are nothing but flooded by the river water. And these rivers carry sand, silt, clay and deposit that in the floodplains. So floodplain is a good area for cultivation of crops. The raised banks are called levees. Okay, the raised banks are called levees or levees. I'll show you. Okay, as the river approaches the sea, the speed of the flowing water decreases and the river begins to break up into a number of streams called distributaries. I will first tell you what a levees is, then I will see here. So you understood waterfall, you understood meander, then oxbow, floodplain also you understood. This raised part, okay, this raised part is called levees. Okay, I will also show that to you in my, I will share my screen and show that to you. Now students, this is how journey of a river takes place, and on the way it creates so many landforms. Okay, now when the river, you know, all the rivers, they drain into the main ocean or the sea. Some rivers drain into, in India, they drain into either Bay of Bengal or they drain into Arabian Sea. Now the time when the river is going to drain itself into the Arabian Sea or Bay of Bengal, its speed reduces. Already I told you, because from the mountain when it comes, due to the slope, speed is high. But once it's at the end point, the speed decreases. When that speed decreases, students, smaller rivers from the main river separate from the main river. These are called distributaries. Okay, these are called distributaries. Okay, the river becomes so slow that it begins to deposit its load. Each distributary forms its own mouth. Okay, what is the mouth of the river? The point where the river enters into the main ocean or sea. That part is the mouth of the river when it is going to enter. Okay, and at the mouth of the river, it forms delta. Look here, this is a delta. Okay, what happens is the river has become slow, so lot of smaller rivers called distributaries come out of this river. They also have their own mouth. Okay, they form their own mouth. Now this is the main river and this is the mouth of the river and this is the bigger ocean. So what happens once the river goes and joins the bigger oceans, this green whatever you are seeing, this is all sand, silt, clay which it has brought with it. It deposits everything here and it forms a delta. The most famous is the Sundarbans delta, which is found in West Bengal. Clear? Okay, main river, distributary, and in your book you can see how a delta looks like. Okay, do you know there are thousands of small waterfalls in the world? The highest waterfall is Angel Falls of Venezuela in South America. Okay, they are at a very great height. These are called as Angel Falls. Okay, the other waterfalls are Niagara Falls, located on the border between Canada and USA in North America, and Victoria Falls on the borders of Zambia and Zimbabwe in Africa. Any doubts still here, students? Please let me know. See, this is how waterfall is taking place. Okay, this is called a plunge pool. Okay, my voice is cutting. Niagara Falls is here. Okay. Yes, Karnataka has a lot of waterfalls. Angel Falls in South America. Victoria Falls on the border of Zambia and Zimbabwe. Okay, here. Formation of Oxbow Lake also I told you. Okay, waterfall, Oxbow Lake, floodplains, delta I told you. This is called the course of a river. How a river starts and completes its journey. When it is in the upper part, it is faster. Here it is a bit slower and it becomes slower over this region. Okay, see here, delta formation, estuaries. Okay, I will tell you what is an estuary also. These are levees which are raised parts, then river. Tributary is in the higher reaches, distributary is over here. Okay, meandering river, Oxbow Lake, source, river system. I will tell you what is an estuary as well. Estuary is the mouth of a river, the wide part where it joins the sea. Okay, you can see in images how it looks like. Okay, one, it is formed near a delta only. Okay, biggest falls are Angel Falls in Venezuela, which is in South America. Okay. Okay, this I already explained to you how a waterfall is formed, Oxbow Lake, floodplains, and delta is formed. Okay. 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 See, erosion and deposition. So what happens? There will be deposition here, deposition here, deposition here. So it will get cut. Oxbow lake will be formed, which are also called as cut-off lakes. Okay, formation of floodplains, flooding of the neighboring areas. It deposits sediments and forms the floodplains. Okay, how delta is formed? As the river approaches the sea, the speed of the water decreases. River begins to break up into a number of streams. These are distributaries, forms delta. Okay, and I want to tell you one more thing. Erosion. Okay, now we will start with the next topic, students. I already completed this. Now we will see that how sea waves, all of you have been near the sea, I hope, or I guess even if you have not, you have seen sea water in the movies. So how do the waves that come in the sea forms various landforms? That is our next topic. Before that, I will give you mic option. Yes, Ananya. Yes, Ananya.
Good evening, ma'am.
Yes, good evening, Ananya. Please tell me.
Ma'am, basically the book that our school follows this book, ma'am. Can you see?
Okay.
So I don't have this chapter.
Oh, but show me the contents. Maybe similar topic will be there.
So, ma'am.
No. Okay. Can you bring it closer? Can you read it? I can't see.
Ma'am, geography, our environment,
Hmm.
land and interior of the earth.
This only. I think it is this only.
Okay, ma'am.
Okay, 1 minute. Read the third chapter.
Process and changing the face of the earth.
Ha, that only it is. Same chapter. But different
Ma'am,
book.
ma'am, second or third one?
Third one, I think.
Okay, ma'am. Thank you, ma'am.
Yeah.
Uh,
Yes, Kana.
yes, ma'am. Ma'am, I'm following this book only.
Yeah, same book I'm also
Yes,
reading.
ma'am. Ma'am, like my sister also has the book that she sold Ananya. Ma'am, NCRT is following two books. Which one your school want? It is your choice.
Okay, is it?
Yes, ma'am.
Actually, I think book is different, but topics are same only.
Yes, ma'am. Topics are similar, not same exactly.
Yeah, similar, but maybe not same word to word, but similar topics.
Yes, ma'am.
Okay. Yes, Pruha.
Ma'am, I have a doubt that you said that longest waterfall is Angela Falls, but after few slides, there was also biggest waterfall. I was not able to read that. Ma'am, can you repeat, please?
Yeah, first is Angel Falls in Venezuela, which is in South America. Then you have Victoria Falls near Zimbabwe and border of Zambia, I think. Yeah, Victoria Falls near Zambia and Zimbabwe, and this one is Niagara Falls on the border of USA and Canada.
Okay, ma'am.
Actually,
So,
I have seen these falls, students. It looks really good. Yes, Spruha.
ma'am, Victoria Falls is the biggest, right?
No, not Victoria Falls. It is highest waterfalls is Angel Falls of Venezuela. Niagara Fall is another important waterfall on the borders of between Canada and USA. Yes, Victoria Falls is the world's largest, like large, like this. Longest is
Oh,
Angel Falls. Largest is Victoria Falls.
okay, ma'am.
Okay, thank you.
Thank you, ma'am.
Yeah, okay, Ananya, no issues. Okay, now we will go to the next part, students. Let's complete this chapter today. Okay, please pay attention now. First, I told you that how rivers form these landforms like Oxbow Lake, meanders, waterfalls, etc. Now we will study what are the work of the sea waves. Okay, the erosion and deposition of sea waves gives rise to coastal landforms. So whatever sea waves are doing, erosion and deposition by sea waves, it gives rise to landforms in the coastal areas, because obviously, like which are the coastal states of India which have a coastal line, like Gujarat, Maharashtra, Kerala, um, parts of Karnataka. Okay, then you have Tamil Nadu, Andhra Pradesh, Telangana, Odisha, West Bengal. So near these places in India, you can find these landforms. Okay, if we talk about India. Sea waves continuously strike at the rocks. You have seen there will be rocks and sea waves are continuously striking. Waves come, strike the rock, go back. Cracks develop. Yes, I told you it will not happen in one day. It will take hundreds, thousands of years for that to happen. Cracks will develop. Okay. Over time, they become larger and wider. Thus, hollow-like caves are formed on the rocks. They are called sea caves. What is this sea cave? It is nothing but the water has hit that part so many times. What water? Sea wave has hit that part so much that weathering of rock has taken place due to the water hitting it again and again and again. It's not happening in 50 years or 100 years. It takes more time, lot of time. And then you can see hollow like sea caves formed. Okay, as these cavities become bigger and bigger, only the roof of the cave remains, thus forming sea arches. You can see here, what is a sea arch? Same thing, from cave it becomes an arch. So it becomes so bigger and bigger that only the top part is flat and it forms a sea arch. Further erosion breaks the roof and only walls are left. Now this also gets broken. Okay, now more erosion, erosion, erosion. This part will be gone. So now you have something like this, okay, which is called a stack. Okay, a sea stack. You can see here, actually this was a rock here, but due to continuous erosion, it forms features like stacks. Okay, sea water is called, 1 minute, the steep rocky coast rising almost vertically above sea water is called sea cliff. Okay, sea cliff is nothing but the cliff near the sea. Okay, no need to worry. That is sea cliff. The sea waves deposit sediments along the shores, forming beaches. How are beaches formed? These sea waves only, they are bringing that sediments. They are depositing. Once the wave comes, it will deposit. Once the wave comes, it deposits. So much sediments is deposited that it forms a beach. Understood? First, sea caves, very easy. From sea caves, more erosion, sea arch is formed. More erosion of sea arch forms stacks. And you know how a beach is formed and what is a sea cliff. Okay, very easy. These are the landforms formed by sea waves. Okay, now we will go to ice, glacier, and at the last we have wind. Let's complete it today. Okay, work of sea waves I already told you. Okay, this is the same thing that I taught you. See here, sea cliff, cliffs. So so what is this? Sea cave. Once it is more, like if I cover this much part, okay, if I cover this much part, it will form a sea arch. If I break all this thing, it will form a stack. Okay, the sea waves deposit sediments along the shores. Due to this, beaches are formed, right? See here, waves forming beaches, because they will deposit all the sediments on one side. Okay, now we will go to how glaciers, ice sheets, form landforms. Okay, glaciers are rivers of ice. What is the meaning of glacier? These are sheets of ice or rivers of ice which erode the landscape by bulldozing soil and stones to expose the solid rock below. So they are also taking away all the stones and all that, soil, and they are actually exposing the solid part of the land. Okay. Glaciers carve out deep hollows there. As the ice melts, they get filled up with water and become beautiful lakes in the mountains. The material carried by the glaciers, such as rocks big and small, sand and silt, gets deposited. These deposits form glacial moraines. See here, students, how do the glaciers form structures? By bulldozing. Like how a bulldozer machine works, it is taking away the soil and stone. Okay, then what happens? That area will become hollow. When that area becomes hollow, that hollow area will be filled with water. Okay, that forms a lake on the mountain. Okay, and creates lakes. Okay, then there is also called as glacial moraine. Now what is a glacial moraine? I will show you that. Okay. I will show you. Glacial moraines are landforms created by the glacial till, which is a mixture of rock, sand, and clay transported by glaciers. So it is nothing but something that is transported by the glaciers. So you can see these are all moraines. Okay, so what is it? It is nothing but sand, silt, clay deposited by the glaciers. Okay. I'll just show you. Is there a short video? You can watch video yourself, students, but I hope you understood. They are created by deposition of glacial till. What is glacial till? I told you, no, it will take away the sand, pebbles and everything. So once it takes that, it will create and it will deposit it somewhere. That only is a moraine. Okay, and the area which becomes hollow, it forms lakes. Okay, there is a name for that. I'll tell you what is it called. I don't know, in this book, no, it's not there. Anyways, I hope you have understood that. Okay, what is a glacial moraine? So no need to worry. Glacial moraine are, you saw the picture, right? So all that what is deposited by the flow of glacier is called a glacial moraine. Okay, and what is that lake? How that lake is formed? Because when once that area becomes hollow, the glaciers, when once they come down, they have taken away all that and made that area hollow. That hollow area, once it gets filled with water, or when once the ice melts and fills it, it forms a glacial lake. Okay, so this also you have understood. See, this is the picture. This is glacial moraine. This is a lake formed due to glacier erosion. Okay, moving on. Last topic of the day, wind. How does wind cause lead to the formation of landforms? Okay, so there is a picture of sand dunes in your textbook. Have you ever visited a desert? Try to collect some pictures of sand dunes. An active agent of erosion and deposition in the deserts is wind. Students, let me tell you, all these agents like wind, water, ice, they are agents of erosion and they are agents of deposition also. Okay, somewhere they are taking away the eroded material and they are depositing that eroded material somewhere. Okay, so they are both agents of erosion and deposition. Okay, now the most active agent in the desert for erosion and deposition is wind. Okay, wind is what? Moving air is called wind. In deserts, you can see rocks in the shape of a mushroom. These are called mushroom rocks. Look here, in deserts you will see rocks like this which are called mushroom rocks. How can wind lead to the formation of mushroom rocks? Winds erode the lower section of the rock more than the upper part. Therefore, such rocks have narrower base and wider top. Imagine the wind is blowing in this desert area, but it is blowing at such a high speed in this area compared to the upper area. So what happens over hundreds, thousands of years? The same process is happening. So it will lead to erosion of the lower part, not the upper part. So the structure that forms is called a mushroom rock. Now it depends. For example, here you can see the top part is completely like a mushroom. Here you can see some differences are there. So that is because of the velocity of the air, wherever it is blowing at a higher speed. So mushroom rocks are one of the features that are formed due to the activity of the wind. Okay. When the wind blows, it lifts and transports sand from one place to another. Obviously, when the wind is blowing, it is carrying sand and depositing it somewhere, right? When it stops blowing, the sand falls and gets deposited in low hill-like structures called sand dunes. What are sand dunes? You will see these are like hilly areas of sand. How does that sand dune even form? Now the wind is carrying that agent. I mean, a wind is an agent of erosion carrying the sand, right? Now, once the wind stops, the sand falls down, and all that sand gets deposited in one place and forms small hills. These are called sand dunes. When the grains of sand are very fine and light, the wind can carry it over very long distances. Obviously, what is the science behind this? If the wind is not able to carry heavier sand, it will deposit it, because the wind has to flow for a longer time, right? If it has to go farther and for a longer time, it can carry small particles of sand, not big particles. So it will deposit that in that place. When such sand is deposited in large areas, it is called lows. Okay, like large areas, it is called lows. Okay, large deposits of lows is found in China. I will show you how they look also. Loess. So here you can see Loess. So here you can see these are all maybe from China, these pictures, because yeah, so it is in China. So here you can see over vast areas they have formed. Now these are not formed in a day or two. It takes a lot of time, okay, for its formation. Okay, levee also I had to show you, right? This part only, like raised part, this raised part next to the river. Okay, this is called a levee. So students, with that we have completed the chapter. Okay, if you have any doubts, please let me know. 2-3 questions I will ask you now. Okay, first question. Mushroom rocks are found in desert. Option A. Option B, river valley. Option C, glaciers. 80% of you have answered it correctly. Very good. It is desert. Next question. Oxbow lakes are found in option A glaciers, option B river valley, option C deserts. Okay, 66% of you have answered it correctly. Which is not an erosional feature of sea waves? Which of them is not an erosional feature of sea waves? Option A cliff, option B beach, option C sea cave. Which of them is not? 31% of you have answered it correctly. It is option B. Students, sea cave and sea cliff is formed due to erosion. Beaches are formed due to deposition. The wave is depositing the material. It is not eroding it. I hope you understood. Okay, so with that, we have completed this chapter. In the next class, we'll start with a new chapter. Okay. All of you have collected 7. Ananya, Kushal, Kanav, Suvi, Arna. Thank you, students. Bye. Take care.